Occasionally you'll see an equation that involves fractions. The process for solving this equation isn't different than solving any other equation, but it does require you to pull back some old skills. We're going to go back to the basics. Let's do a quick review of addition and subtraction of unlike fractions. Before you can add or subtract fractions, you have to have a like denominator. So we have to find the LCM, the lowest common multiple. This is also sometimes referred to as the lowest common denominator. In order to do this, I'm going to take my denominators 8 and 12 and list out their multiples. It's just like skip counting. 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32. 12 times 1 is 12, 12 times 2 is 24, 3 times 12 is 36, 4 times 12 is 48. I see that they both have 24 in common in both lists. I'm going to multiply 8 by 3 because 24 is the third multiple. I'm going to multiply 12 by 2 because 24 is the second multiple. So I'm going to make equivalent fractions with this new denominator. Like I said, I'm going to multiply by 3. That'll give me 9 24ths. I'm going to multiply by 2. That'll give me 6 24ths. If I end up with a common denominator, I've done things correctly. Now, I can just add or subtract the numerators following your negative rules. 9 plus 6 gives me 15. The denominator is going to stay the same. 15 over 24. As always with any fraction problem, simplify. 15 over 24, well, I can do my mountain method. I'm going to write out the multiples of 15, multiples of 24, or sorry, factors of 24. 1 times 24 is 24, and then I climb the mountain. 2 times 12 gives me 24. 3 times 8 gives me 24. 4 times 6 gives me 24. 5 gives me a decimal. I can always check that by checking 24 divided by 5. It doesn't have a whole number factor. 6 would be the next number I check, and it's on the other side of the mountain, so I have all of my factors listed out. I need to find the biggest factor in both triangles or both mountains and divide numerator denominator by that greatest common factor. Gives me a fraction of 5/8. There's my final answer. Let's try one more together. I need to find a common denominator, so I take my two denominators and list out the multiples. It's just like skip counting, or use your calculator. 6 times 1, 6 times 2, 6 times 3, 6 times 4, 18 times 1, 18 times 2, 18 times 3, etc. Find the smallest number in both lists. In this case, 18. We want to find a value that's in both of these lists. If you're listing out your multiples and you don't see a common value, then keep listing. It'll show up eventually. Some students choose to use the shortcut of multiplying both factors, or the opposite factor or fraction, by the denominator. So I'd multiply 1/6 by 18 top and bottom and 5/18 by 6 top and bottom. This requires a lot more simplifying in the final answer. It makes finding a denominator very easy, but makes finishing the problem very challenging. So I'm going to multiply my fraction with 6 by 3 because 18 is my third multiple in that list. I'm going to multiply my fraction that has 18 as a denominator by just 1, or I don't have to do anything to it because 18 is the first factor, or multiple. 3 plus 5 gives me 8. If we were subtracting, all we do is subtract the numerators. The denominator stays exactly the same, and then we simplify. I'm going to set up my factors. 1 times 8 is 8. 2 times 4 is 8. 3 is not a factor. I can always check this by simply doing 8 divided by 1, I got a whole number. 8 divided by 2, I got 4, a whole number. 8 divided by 3, I get a decimal. It's not a factor, so the next factor has to be 4. I'm going to do the same thing with my factors of 18. 18 divided by 1 gives me 18. 18 divided by 2 gives me 9. 18 divided by 3 gives me 6. 18 divided by 4, 18 divided by 5 give me decimals. My GCF, my greatest common factor, is 2, so I can divide top and bottom by 2. You can also just find the factors of one of the values, usually the smaller value. All things being equal, a smaller value usually has a smaller amount of factors. This isn't always the case, but it's consistent enough that it'll save you some time in the long run. If I use just those factors of the smaller value, I would then take 18 divided by 8, which would give me a decimal, 18 divided by 4, which gives me a decimal, 18 divided by 2, that's my greatest common factor. I just find the factors of one value and divide them from my other value. On your own, go back and try this problem. Remember, once you have a common denominator, just subtract your numerator. Keep the denominator the same, and then simplify. On your own, try to figure out what value could x equal that would make this statement true. Describe how you solve. Describe where that value came from. Equations are all about the operation, not about the values involved. So the fact that we have fractions in this equation in no way changes how we solve the equation. However, you do need to keep your fraction skills in mind for when you evaluate the final solutions. Always start with the same two questions. What's happening to the variable, and how do I undo this operation? What's happening to my variable? I have x plus 3/5 equals 13 over 15. Sometimes it's as easy as reading the equation. X plus 3 over 5. So I'm adding 3/5. How do I undo the operation? I would subtract 3/5 from both sides. I'm going to apply this inverse operation to both sides of the equation in order to keep it balanced. If I subtract from the left, I need to subtract from the right. Now I'm set up to solve my equation. Up to this point, nothing has really changed. And even beyond this point, the only thing that has changed is that you have to use some older skills, your fraction skills. So I'm going to evaluate each side of the equation. 3/5 minus 3/5, we know that's going to give me my identity of 0, which will give me x by itself. That's exactly what we want. 13/15 minus 3/5 isn't as easy. So I might take a little sidebar area and work on this problem. So I'm going to set up 13/15 minus 3/5. I need common denominators. So I'm going to take my denominator of 5, my denominator of 15, and find my multiples. Just like skip counting. I need to find the smallest multiple in both lists. In this case, it's 15. It has to be located in both of your lists. In order to make my fraction that has a 5 as a denominator into 15, I multiply by 3. I know that because it's the third multiple in my list. I don't have to do anything to my fraction that has a denominator of 15 because it's my first factor in my list, or multiple in my list. I don't need to multiply by 1 if I don't want to. So it's going to give me 13/15 minus 9/15. Worry just about the numerator. 13 minus 9 is 4/15. If the equation starts with fractions, leave the answer in fraction form. Let's try a couple more together. We always start by asking ourselves, what's happening to the variable? I see 5/9 equals x minus 5/12. I'm subtracting 5/12. Be careful of those common errors. The 5/9 is not on the same side as the variable. It's not affecting the variable. So to undo subtraction of 5/12, I need to add 5/12. I'll do it to both sides. Negative 5/12 plus positive 5/12 on the right side is going to give me just x when I evaluate. On the left, I need to add those fractions. They have unlike denominators, so I need to find my common denominator. I take my denominators 9 and 12 and list out the multiples. 9 times 1, 9 times 2, etc. 12 times 1, 12 times 2, etc. The smallest value in both those lists is 36. In order to make 9 into 36, I see that it's my fourth multiple, so I'm going to multiply top and bottom of that fraction by 9. 36 is the third multiple of 12, so I'm going to multiply my fraction with a denominator of 12 by 3. I redo these to find equivalent fractions with common denominators. 20/36 plus 15/36. I'm just going to add those two numerators. 20 plus 15 gives me 35. The denominator stays the same. Always check if you can simplify. In this case, I know that I cannot. Let's try this next equation. Negative 3 over 35 plus x equals 12 over 35. Keep in mind that in algebra, there are values that are great for communicating math, and there are values that are great for calculating math. Mixed numbers are great for communicating. Improper fractions are great for calculating. So I'm going to turn negative 1 and 3/35 into a improper fraction. 35 times 1 gives me 35, plus 3 is 38. So this is really negative 38 over 35. I ask myself, what's happening to my variable? I'm subtracting 38/35, so I need to add 38/35 to both sides. I put it on the left, I put it on the right. When I add on the left, I'm going to get my identity of 0. Those are opposites, so when I add opposites, I get 0. 12/35 and 38/35, I still need to add. Now they already have common denominators, which makes life a lot easier. 12 plus 38 is going to give me 50 over 35, and then always simplify. This is going to come down to 1 and 15/35. If I know it's improper, I want to turn it into a mixed number first, and then just simplify the fraction portion of that. So I have 15 and 35. I need to find my greatest common factor. It's the biggest number that both of these have as factors. So I'm going to list it out. 1 and 35. 35 divided by 1 gives me 35. 35 divided by 2, decimal. Divided by 3, decimal. 4, decimal. 35 divided by 5 gives me 7. 35 divided by 6, decimal. 7's next, so I'm on the other side of my mountain. I'm done. Same thing with my factors of 15. 15 divided by 1 gives me 15. 15 divided by 2, decimal. 15 divided by 3 gives me 5. Divided by 4 gives me a decimal. 5's the next number I need to check, and I'm on the other side of the mountain, so I have all my factors. The biggest number in both of these lists is 5. So I'm going to divide top and bottom of the fraction portion of my mixed number by 5. I end up with 1 and 3/7. X equals 1 and 3/7. Always leave your final answer as a fraction. If the equation starts with fractions, it ends with fractions. On your own, try the last two problems. Give them a try. Keep in mind those two questions. What's happening to my variable? How do I undo it? You're going to apply those same concepts, those same inverse operations. The only difference is you need to use your fraction skills when you evaluate the final answer.